welcome guys. So keep solving our physics GRE AD. So AD that the string consists of UG and mu G and mu L, two strings, and there's a wave in. Ask you about what is amplitude is transmitted to the right. Okay, so I suggest that in the test time that you don't have any time to compute it. So the fast way is you just use your common sense. If UR is equal to mu G, then the transmission should be 1. Okay, so which one is correct? The A is not correct, right? Definitely A is not correct. B, so mu R equals to mu G, which is 1. And for C, basically you have mu G divided by mu L. Oh, yes, which is also correct. D is 0 and E is 0. So the answer must be B or C. Also, there's a common sense that when mu R is very large, that means there's a wall, right? So if mu R is very large, then there's no way that you can transmit it. So if mu R is very large, then T should be 0. So mu R is very large, then this is 2, which is not correct. The answer must be C. I think it's enough for this video, and basically you can Google and find any calculation for this true answer. Okay, so I just want to say this because in the subject GRE, right, you usually don't have the time to solve the differential equation or what. So 81 and basically ask you about the so-called bit. Okay, so the bit has two formula. Basically, is one formula is f1 div minus f2 is called a bit. Okay, so so basically you have this 73.416 and another is 440. So 440 divided by 73.410 is close to like 6, right? So basically the closest is this one. I should take the floor. So this is 0.5. So the answer is 6 harmonics and 0.5. 6 harmonics and 0.5. Answer is B. Okay, 82 said that 2 horizontal glass plates and a thin film with air between them, for which way value the thickness of the film of air. Well, film as seen reflected appear bright if it's illuminated by the blue. Okay, so basically you have 2 horizontal glass planes with a thin film of air. So this is glass. Okay, and then you have a light pass in. Okay, and also I use circle means this is the original face. This is original face. And this is T. Okay, so basically from your go in and go back, and basically the time so it travels 2T. It travels 2T. Okay, so 2T just equals to the m lambda. Okay, so this is bright. But this is so remember that this is usual original one. So okay, so if this is okay, so if this lights okay, so how if this light is the is the zero phases, then glass has so in this is also glass. This is also positive phases, but air to the glass is the index small to index large. So there will be another phase difference when it reflected, and so there will be a phase difference when this one to this one, and then when it transmitted, then there's no phase difference. So you see, these two has 180 phase difference. So what we need to modify this formula basically is 2t equals to m over divided by 2t, just use m minus half lambda, which m is 1, 2, 3. So this is the new formula. Okay, so for the lowest one, basically is our t just 4 over lambda and 3 lambda over 4 and 5 lambda over 6. So this is the answer. So be sure to remember to check the phase difference. Okay, so the answer is E. The answer is E. Okay, so 83, basically you have a V and on this wave, and it asks you about for what V will the particle stay on the surface at all time. Okay, so there are multiple ways to solve it. So the different difficult ways that so at each point that your V should at least larger than the GR, or sorry, less than the G times the curvature, right? But the difficult point is this is plane curve. So the plane curve has the curvature. Basically is x double dot y dot minus y dot double dot x dot divided by x dot y dot 3 over 2. Okay. Basically, if you have x of t, y of t, and this is 1 over r. So basically, you can plug your x is t and y is just d times cosine kt, and you plug in. Then you can find at t equals 0, you can get r is 1 over kd squared. 1 over kd squared. Then actually you can, and then you plug in, then you can get the answer is d. You can get the answer is d. Oh, this is MGR, sorry. And this is comes from this, right? Okay, but if you don't remember if you don't remember this formula of the curvature of the plane of the planar curve, then you can still get the answer, right? Okay, so you need to have a feeling. Okay, so the feeling is that if you see d, if d is very large, then what will go in? If d is very large, that means your v need to go to 0. Like, because you have infinite steepness here. So basically, when you need to stay on here, you must have the 0 velocity. If you have a larger velocity, then you will quickly leave the steep. Okay, so which one has this property? The answer is D. The answer is D. Yeah, so this is the easiest way to solve it. Okay, so I think it's enough for today, and I will see you guys in the next video.